Now it's time to focus on storing book and author data into a database and using EF Core to help with that. We'll start by creating a new project that's set up with EF Core. This new project will be another class library project, and I'll call it Publisher Data and make sure that it targets .NET 6. Next, I'll add EF Core 6 APIs to the project using NuGet packages. There are a few ways in Visual Studio to add NuGet packages to a project, and we'll take the easiest path, Visual Studio's NuGet Package Manager. You can right-click on the project and choose Manage NuGet Packages, and that brings up the Package Manager. This starts out showing what's already installed, so I'll go over to the Browse window. And right away, I'm seeing Microsoft Entity Framework Core SQL Server package and another that's just Microsoft Entity Framework Core. Now, I could start by just installing the EF Core package, which is the second one, but I'll very quickly discover that I still need some kind of a data provider in order to interact with my chosen database, in this case, SQL Server. So this base package only has the absolute core of EF Core, and it doesn't have additional logic that covers all the scenarios. For example, EF Core will need to know what database you're planning to work with, and those providers, along with their special logic, are in individual NuGet packages, so you only need to install the provider you want. To bring EF Core in along with this provider, it's easier to start by targeting just the provider package that you're going to be working with, and then let NuGet's dependencies pull in the rest. In this case, that would include the base Entity Framework Core package. As I said, I'm going to be persisting my data in SQL Server Local DB, which got installed as part of the Visual Studio install. So that means I'll need the EF Core SQL Server package right here on the top. The SQL Server package doesn't depend directly on that Entity Framework Core package. If we look here at the details of the package, you can see that it has a dependency on Entity Framework Core Relational. That's where all the logic is that's common across different relational databases that you might be using with EF Core. And if we were to look at the relational package, we'd see that it has the dependency on that base Entity Framework Core package. And just as an FYI, that base package has a dependency on .NET 6, which is already installed on my computer. I know that by starting with EF Core's SQL Server package, I'll get all the packages that I need, and I won't have to go back and keep installing the other ones. So once I've clicked on Install for the SQL Server package, NuGet will kick off and go find all the other packages it needs to pull down. When it's done, I can see the EF Core SQL Server package has been added to the CS proj file. I could have just added that directly into the CS proj file and not bothered with a NuGet package manager. Or I could have used the PowerShell command install-package to get the package installed. And if you're working at the command line with .NET CLI, then you could use the .NET add command. And in fact, when you look up NuGet packages on NuGet.org, you can see the various commands you can use to install them. As long as I have access to the package manager in Visual Studio, that was the easiest path for me. Now that EF Core 6 is in the project, I can go ahead and build a data model to drive the persistence of my books and authors into the SQL Server database that I'll be using. I'll overwrite the class file that was created with the project. I'll name the class pub_context because it will be using EF Core's DB context class. And the class needs to inherit from EF Core's DB context. I'll let Visual Studio add in the Microsoft Entity Framework Core namespace at the top of the class file. The DB context provides all of the logic that EF Core is going to be using to do its change tracking and database interaction tasks. And for those of you who've been using EF6 and haven't yet seen any version of EF Core, I do hope you already feel a sense of relief in seeing the beginning of how similar EF Core is to Entity Framework 6. A DB context needs to expose DB sets, which become wrappers to the different types that you'll be interacting with while you're using the context. The first DB set that I want to create is a DB set of author type, and I'll call that authors. Visual Studio makes it easy to discover and fix needed references. The data project does need to reference the publisher domain, and I'll use the quick action again to easily add the reference to the project. At the same time, Visual Studio also adds the using statement for a publisher domain because it knows that I need that as well. Here you can see that the project reference has been added to the CSproj file. I'll also add in a DB set for the book and rename the class file to pubcontext. How you define your DB context is important to how Entity Framework Core treats your data at runtime, as well as how it's able to interact with the database, and it can define how you use the model in your coding. Because I've exposed both of these DB sets, I'll be able to directly query the authors or the books in my code. The DB context also affects how EF Core infers the database schema, whether you're working with an existing database or you're going to let EF Core create the database using this model. For example, EF Core will presume, by its conventions, that the table names match the DB set names. There's a lot you can do to affect how EF Core infers that model at runtime as it reads the DB context and any other information you might provide. But for now, I'll just stick with the EF Core's defaults, given that I've already made it aware of the author and the book. Further on in this course, I'll provide you with more information about defining and customizing the DB context, and I'll give you some tips and tricks on taking more control over how EF Core interprets your data model by way of this context. This is all EF Core needs to know about the classes it's going to be interacting with, but we still have to let it know about the database. Even though you've already seen me bring EF Core's SQL Server provider into this project, my DB context is still completely unaware of that provider. If you're coming straight from EF6 or earlier, informing the context about the provider and connection string is quite different, so do pay attention. There's more magic in those earlier versions to infer the provider and connection string, but this caused some confusion and some bad side effects. With EF Core, you need to explicitly tell the context what data provider to use and explicitly give it a connection string. There are a few ways to do this. One is directly in the DB context class, and that's what I'll do here. Now, hard-coding the connection string into the context is great for demos and first looks, but not for your real software. Later, you'll see me take advantage of some features of ASP.NET Core to inject this information into a DB context at runtime. In EF Core, the DB context has a virtual method called onConfiguring. I'll add that into my class using the override snippet. OnConfiguring will get called internally by EF Core as it's working out what goes in the model. And it will also pass in an Options Builder object, and you can use that Options Builder to configure options for the DB context. We won't need this base onConfiguring call, so I'll delete that. Notice that the Options Builder has a method called useSQLServer. That's an extension method, and it's available because I've got a reference to the Microsoft Entity Framework Core's SQL Server API. If I had pulled in the SQLite provider, I'd have access to a method called useSQLite. And if I had referenced SQLCE, I'd have useSQLCE as an option, and so on with other providers. So I'll choose the useSQLServer method, which expects a parameter that's the connection string. And this is how, in a single statement, I can tell the DB context, hey, you're going to be working with SQL Server, and here's the connection string to the database that I want you to use. And that points to the local DB SQL Server instance and specifies that the database is called pubDatabase. Now, in my case, the database doesn't exist yet, but there are a number of ways to let EF Core help you create a database. And that's possible because EF Core is able to read the model that this DB context describes based on the classes that it's pointing to. And it can do it on the fly at runtime, or you can explicitly do this at design time. And you even have the option of letting it create the database directly or just having it create SQL scripts. The first time EF Core instantiates the pub context at runtime, it will trigger the onConfiguring method, learn that it should be using the SQL Server provider, and at the same time be aware of the connection string. So that way, it will be able to find the database and do its work. With all of this in hand, we can already let EF Core read data from and write data to the pub database. I'll start by making sure that the console project also refers to the new publisher data project, and then I'll get rid of the initial hello world call. For this very first demo, we'll cheat a little with a method that's good for limited scenarios, beginner demos being one of those scenarios, in order to quickly make the database available. The cheat is that I'm going to instantiate the pub context, drill into its database property, and then call the ensureCreated method. This will cause EFCore to read the provider and connection string defined in the pub context class, and then go look to see if the database exists. If it doesn't, it'll read the context and determine what the database should look like, then go ahead and create the database on the fly. In my case, the database doesn't exist yet, so EFCore will perform that task when I first run this program. Next, I'll quickly add in a method called getAuthors, and I'll make sure that the program calls the method as well. This creates a new instance of the pub context, then drills into the authors DB set that we defined, and calls a link method toList. LINQ stands for Language Integrated Query and is built into C# and into VB.NET. The toList method forces the query to execute on the database and returns a list of the objects. Once those are returned, I'll iterate through the list and spit out each author's name to the console. If I expand Visual Studio's SQL Server Object Explorer, you can see there's no pub database yet. Now I'll debug this little app by pressing F5. There's a short pause while EFCore looks for the database and then tells SQL Server to go ahead and create it. Then it outputs the message from the getAuthors method. But we haven't put any authors into the database yet, so there's nothing listed here, just the message that the console app spits out by default after it's finished processing. But when I refresh the list of databases in the SQL Server Object Explorer, you can see the pub database is there now. And drilling further in, there's the authors and books tables, and even further, all of the columns that were created based on what the DB context learned about the author and book classes. And using EFCore's conventions with some input from the provider about how to translate .NET types into database types. I've added another method called addAuthor, which creates a new author object. And keep in mind that because we're using the author type directly, you'll need a using statement for publisher domain at the top of the file. Then instantiates the pub context again. This time, I'm using an add method on the authors DB set to add this new author object to the authors DB set. So now the context is aware of this new author. And finally, I call dbContext save changes. That method triggers EFCore to open the database and push the author into the authors table. Notice that my program now calls getAuthors, then addAuthor, and then getAuthors again. Now when I run the program, the first getAuthor will still be running against the empty database. But after I call addAuthor, the second time I call getAuthors, it will finally discover some data and relay it to the console. So let's go ahead and debug the app again, and now I can see the output from the second getAuthors call, showing the author name, Julie Lerman. Now I'm going to go back and modify the addAuthor method, changing the author to our new dog, Josie, who is in Newfoundland, so I'll pretend that Newf is currently her last name. Now when I run the program, the first getAuthors call shows the Julie Lerman author that already exists in the database. Then the addAuthor method adds Josie, and then the second getAuthors call lists all of the authors, so that means seeing my name again and Josie. And if I open the authors table, you can see both of those names listed. Notice also that each row has the ID populated. By convention, EFCore knows that SQL Server will generate those IDs for me because another convention for EFCore is that a property called ID is a primary key. So I didn't have to worry about providing values for the IDs when I created the authors.